Hello and welcome to this video on writing and balancing chemical equations. Today we're going to take a look at just the basics of how to balance chemical equations using some tricks and tools, and then also how to use a sentence and go from that sentence into the skeleton equation in order to be able to determine what we have. And so this is kind of the basic of where we'll start. So we can see here, this is actually a diagram that represents some atoms that are being changed into different molecules. And so we see that this one starts with CH4 and O2, and it ends up producing CO2 and H2O. And we see these numbers at the beginning, and what we're going to learn is that these things are called coefficients, and this is what we use to actually balance the equations. We do not, in any way, shape, or form, want to use these guys in order to balance. Okay, so they're very important that they're on there. That tells us what our molecules or our compounds are going to have, but we do not want to use those in order to balance. We only want to use the coefficients, which are at the very beginning of each one of these. So these are coefficients, and this is what we use to balance. So grab your notebook and let's get started with all the basics of writing and balancing equations. All right. So the first thing that we want to know is we just want to kind of have this basic understanding of what's going on in a chemical equation. So chemical equations are representing our chemical reactions. And so we have our reactants, which are always on the left-hand side. So we'll always see the reactants on the left-hand side, and we'll see an arrow between them and the products will always be on the right-hand side. And that arrow is telling us that there's been a change in the chemistry that's going on there. And so we want to make sure that we know what's on both sides of the equation, and we want to be able to represent each and every one of those atoms and their different compounds. So these equations are the representation of chemical reactions, and they show that matter is conserved. And that's one of the reasons why we're going to balance them. So we see the same type of elements on each side of the equation, and we also see that the numbers of each individual element should be the same on both sides once we go through and balance them. We also use symbols to represent the state of matter. Now, I'm a little lax on this with certain reactions, but with others we need to really make sure that we're doing those correctly. And so you want to jot these down and make sure that you know them because they'll come up again. So we see that solids are represented with a lowercase s, and liquids with a lowercase l, and we put these in parentheses after the compound formula. We'll see that gases are a lowercase g, and then finally we'll get to see aqueous, which is AQ, and that means that it's an ionic compound or something that's been dissolved in water. And so we'll see these probably actually when we get into a little more information about single replacement and double replacement reactions is where I tend to pull these out a little bit more. But just be aware of what they are, and if you see them again, you'll know what you're looking for. Okay, let's talk about just some basics of balancing. And so I'm going to give you a very simple example to get started. We'll have lots of practice on these. And so the one I'm going to start with is going to be the actual formation of water. So we start with H2, and if we're going to do this, it could be a gas, okay, plus O2, which is also going to be a gas. We'll talk about those in just a moment. Now, I'm going to actually make H2O because I'm saying that this is the formation of water. Could you form H2O2? Well, yeah, and usually it breaks down into H2O because it gives off some other stuff. And in this case, we'll just say that H2O that formed is going to be a gas, okay? So this is how we represent those symbols afterwards. Now, what I do when I go to balance these equations is I take an inventory, and I'm very systematic. This is a pretty easy one to do, but I'm very systematic on these. So what I do is I draw a line that goes down from my arrow, and once you get better at these, you won't have to do this as much, but I still, if I find one that's challenging, I go back to this method. So what I do is I write down each and every element that I have, and I should have the same elements on each side, and I take an inventory. So on this side I see that I have 2 H's, so I write 2, and I have 2 O's, okay, so the O2 tells me that I have 2 oxygen atoms, and then over here I have 2 H's, so H2 says that we have 2 H's, but we only have one oxygen on this side, okay? Now what I want to do is I want to change my coefficients, those numbers at the very beginning, in order to be able to balance this. So what I want to do first is I want to make this a 2. Now, when I make that a 2, that gives me 2 H2O molecules. So that's saying H2O plus H2O. So I have a total of 2 oxygens now, and what I do is I cross this out and I write a 2 here to represent that I changed that to be 2 oxygens. However, when I change that to be 2 oxygens or 2 water molecules, now I have 2 plus another 2 hydrogens, or I can take this 2 here, okay, and I can multiply it by this 2 here to get a total of 4. So I cross out my 2 hydrogen and now I have 4 hydrogen. The great thing is that my oxygens now match up, but my hydrogens do not. So I need to use a second coefficient over here in order to get 4 hydrogens on this side. And so if I take 2 times the 2 hydrogens that I have here, that actually gives me a total of 4. I go back and I double check each one of these, so I have 4 of each of the hydrogens, I have 2 of each of the waters, and I end up with a balanced chemical equation showing that matter has been conserved in this process. And so those are the steps that I take in order to do that. And like I said, once you get good at these, you can usually do them a little more quickly, and then whenever you get to one that's maybe a little bit of a struggle, you can go back and use this method again. It works really quite well. I used to use it in college all the time when I would get stuck. Okay, so now that we've seen that, let's take a look at a couple other things that we need to know. One of them is remember the diatomic molecules, okay? So those are the things that in nature, these will actually form. So in nature, they're going to form, okay? And we remember that trick where we start at number 7 and we form a 7, and so these are going to be all of these ones. So we're going to end up with N2, O2, F2, Cl2, Br2, and I2. So whenever you see these listed, we also know that hydrogen does that too, so H2. So if you see hydrogen written out, hydrogen in nature is always going to be H2, okay? Nitrogen in nature is always going to be N2, and oxygen in nature is always going to be O2. So no matter what, when you're reading these, you're going to notice that and you're going to use it. And so remember that when we go to the next slide here and we start to see these sentences that we have to figure out. So here's our first one. It says water is separated to form hydrogen and oxygen. So the first thing that we need to do when we're writing chemical equations is we have to actually utilize the information. So we see that water, okay, so water we know is H2O, so you have to know some information. Is separated to form hydrogen and oxygen. Now remember, hydrogen and oxygen are both diatomic molecules in nature. Anything else that's not one of those diatomic molecules will just be itself. So in this case, we're going to see H2 and O2. So that's what I know I'm working with. Now, it's separated. This is that arrow, okay? So there's different words that can represent that arrow. So I'm going to write H2O is separated or is changed to form H2 and O2. So we see that this is now going to be my reactant, and both of these are our products, and we're separating them with that arrow. So just keep that in mind. Now once I've done that, I want to go through and I want to again balance those equations. So I'm going to have my H and my O, and my H and my O, okay, on each side, and I want to account for each one. So we've already done this. We're just doing it the reverse way now. Okay, 2 and 2. So I'm going to make this a 2 here, and when I do that, that gives me 2 oxygens, but it gives me 4 hydrogens. And you want to make sure you're keeping tally on each one of these as you go. So I have 2 here, and now I get 4. If you don't do that systematically, sometimes you'll goof up, and you don't want to do that on these. Okay, so that's just one example. Let's do a couple more here. So the next ones that we're going to take a look at, you want to really go back and remember all of your ionic formulas. Remember, we determined using our periodic table of ions, and so we had to use the charges, and we had to balance the charges. We used the crisscross method unless they were the same charge number in opposite directions, and then they were a 1-to-1 ratio. So you might want to go back and rewatch the video on that if that was a struggle for you or you just don't remember. And we're going to see some of these in practice here. So let me get to the next slide. Okay, so this is going to be lithium and chlorine react to form lithium chloride. So I see the reactive form means that that's going to be my arrow. Okay, so the reactive form, oops, that's not where I wanted to go. Let me go back one. There we go. So the reacts to form is going to be my arrow. Lithium is not a diatomic molecule, so on the periodic table it's just Li. Chlorine is a diatomic molecule, so it's going to be Cl2, and then lithium chloride. And if you remember, lithium is a +1, okay, Li is a +1, and Cl is a -1, so it's going to be LiCl. So there's some information there that you're going to have to go back and use skills that we've learned before. So now all I do is I go, well, lithium plus Cl2, and it's actually a gas, so I'm not going to write that today, but forms lithium chloride, LiCl. Okay, so and those are going to be together here. Now I want to go ahead and balance these. This one's a pretty easy one to balance, but I'm going to go back and use that method again, Li and Cl, and once you get good at these, you can kind of start to streamline this a little bit. And so I see on this side I have one of each, and on this side I have one lithium, but I see that there's a 2 after the chlorine, so I have 2 chlorides, or 2 chlorines, excuse me, not chlorides. Okay, so now I have to make my chlorines match, and the thing that I have to do is I'm going to use my coefficient of 2 right there, and so that's going to give me 2 chlorines, which is fabulous, but it also changes my lithium to be 2 lithiums, because remember, we're multiplying times everything we have here, and since we have one of each of them, put that coefficient at the beginning, we have 2 now. So now I have to go back to this side, and I have to add my coefficient here. Okay, and that means I'm going to have 2 lithiums now, so I can go ahead and double check that. I have 2 of each one of those, and it's balanced, and so that's a great thing to be able to do, and we're going to do more practice. Let's do one more, and then I will set you free to do some practice. So here is the last one for us today. So magnesium chloride and sodium hydroxide, and they're going to react. Let me get me out of the way here. React to form magnesium hydroxide and sodium chloride. So let's go back and use each one of those tools. The react to form is telling us this is going to be our arrow. Okay, and so magnesium chloride, if you remember, magnesium has a 2+ and chlorine has a 1-, so this is going to be MgCl2. Okay. Sodium hydroxide is going to be Na, and hydroxide, it remembers a polyatomic ion, so that's going to be OH. And they're going to form magnesium hydroxide, so Mg, and that OH has a -1 charge as well, so it's going to be OH in parentheses and the 2 on the outside, and then sodium chloride, which is just NaCl. So that's kind of my preliminary work. Now I want to put all of that information into my equation. So I'm going to have MgCl2. Now the things that we start with are reactants, so they're going to go on the left-hand side, plus NaOH, and I leave a little bit of room there for me. Okay, my arrow, and now I'm going to do MgOH2, 2 on the outside, plus NaCl. Now the cool thing is when I do this, if I see that the polyatomic ion, so here's my polyatomic ion of OH here and OH here, it doesn't get separated, then I actually count for them together in the tally below here when I go to balance. If it gets separated, then I have to split them apart into the individual atoms. So in this case, I actually am going to leave them together. So I see I have Mg, I have 1 on this side, Cl, I have 2, Na, I have 1, and OH, I'm going to keep it together, I have 1. Okay, on this side I have Mg, and I'm going to have one of those, and I put it in the same order just to help me. So Cl, I have 1 over here. Sodium in A is going to be 1, and then OH on this side is 2. So what I need to do is I see that I have 2 chlorines on this side, but I only have 1 over here. And so I'm going to use my coefficient of 2 in front of the sodium chloride. So I put a 2 in front of there, and that means now I have 2 chlorines, but I also am going to have 2 sodiums now as well. Okay. On the other side here, now that I have 2 sodiums, well, I only have 1 sodium here, so I want to actually put a 2 in front of the sodium here. And when I did that, I changed my sodium to be 2, and I also changed my hydroxide to be 2, and actually that ends up balancing our equation because we have 2 hydroxides on this side and 2 hydroxides on the other side. So I hope that was a helpful method for you. I highly encourage you to use that, especially to get started, and then whenever you run into a tougher equation to balance. We're going to practice working on those balancing chemical equations and being able to write them, because those are skills that all chemists need to know. I hope that was helpful. Thank you.